Hi everyone, and welcome to the Docker Crash course. So let's get started with the course overview. Right, now the first thing that we're going to cover is the definition of Docker. So we want to look at what Docker is. Then we want to take a look at the pre-Docker problems. So these are the problems that existed before Docker became as mainstream as it is today. We then want to look at why we should utilize Docker. Then we're going to learn how we can install Docker locally on our machines. After which, we're going to look at the comparison between Docker images and containers. And then we'll dive into Docker registries. So we're going to look at the difference between public and private registries, which we get in the Docker ecosystem. After which we will take a look at Docker image versions. And this is going to be followed by a practical lab exercise, which is going to be focused on evaluating the main Docker commands that we would utilize. After which we're going to dive into port bindings. So I'm going to explain the difference between container ports and, of course, host ports. This is then going to be followed up by a lesson on taking a look at how we can start and stop our Docker containers. And after that, we're going to learn how we can create our very own Docker file. All right, so that's it in terms of the introduction. So let's go ahead and get started. All right, so let's take a look at what Docker is. So what is Docker? Simplified. Okay, so in a simple way, Docker is essentially a virtualization tool that simplifies app development and deployment. Now, it does this by bundling the app with everything that it needs. This includes dependencies, system tools, settings, and even runtime into a container, which is going to be known as a Docker container. And this is going to ensure that it runs smoothly anywhere. Now, this is going to be simplified in a demonstration. So let's say we have our application code. We then have the packages and the dependencies. And then we also have our runtime. And we also have all of our environmental configurations and everything. And all of that together is then going to be packaged and transformed to run as a Docker container as the end result. So this is the simplest way in understanding Docker. Okay, now let's go on ahead and make this simpler by looking at an analogy. So try to think of a container like a lunchbox. Okay, so you would have your lunchbox, and then in your lunchbox you would have your meal. This could be seen as your app or your application. Then you would have your cutlery. So this can include, of course, your forks and your spoons. This will be your dependencies. And then you would have your napkin, and this can be seen as the settings. Right, so that is the simplest way in which we can go ahead and look at what Docker is. All right, so now let's go deeper and look into pre-Docker problems. So to be specific, we're now going to look at the problems that many developers would have faced before Docker or without using Docker. So let's take a look at a common use case. So imagine that you have gone ahead and decided to build a Python app, and it works perfectly in your laptop or your desktop. Perfectly fine, no issues whatsoever. And then you decide that you want to send it to a friend or you want to deploy it on a server, but then you notice that it doesn't work. So you wreck your brain for hours and hours thinking, why on earth does this not work? Because every machine has different settings, dependencies, and configurations, and this is the reason as to why this error occurred. Now, to continue with this, we can take a look at an example problem here, just to build on. So you had in that project that you built, you had Python 3.11, the version, but the server only has Python 3.8, so your code breaks. Your app needs Django 4.2, so Django is essentially a Python web framework, just for clarity, and the server has an older version, so it crashes. And you also forgot to install a required library, and now the app won't run. So you can see here the list of issues that can occur if you do not utilize Docker. So this is a typical situation where you need to manage everything exactly as is in every possible way. So what is the issues here and what are the problems that we are facing that we don't like? So the issue here is we would need to set up a new environment, and that's going to take too much time. Moving an app from one computer to another is frustrating, and to deploy to a server at this moment feels like a total nightmare. So how does Docker fix this issue that we were having? So Docker is going to package everything that the app needs, and this includes the code, the dependencies, the runtime, and the system settings into a container known as a Docker container. Now your app runs exactly the same everywhere, and this is going to include on your laptop, on a colleague's computer, and also on a cloud server. All right, so here's how you can see the benefits start to come up with the utilization of Docker. All right, so let's take a look now at a few points as to why we should use Docker. All right, so why use Docker? So by utilizing Docker in your software development workflow, some of the benefits will include the following. Now, the first thing is that it works everywhere, so you can run your app on any computer without any issues occurring. There is no more of the following statement, which is that it works on my machine only. These kind of problems. It will always follow the same setup always. It is also very fast and lightweight, and it's going to in turn use fewer resources than virtual machines. And finally, it is very easy to share, so you can just simply package your app once and run it anywhere. So here are the key benefits to utilizing Docker. All right, so let's continue and learn how we can install Docker on our machines. So what you're going to want to do is type in Docker desktop within a search engine of your choice. So I've got it typed in. I'm going to do Google search, and here we come up with Docker desktop, the #1 containerization tool for developers. So we can click on this link. All right, and that's going to take you to the following page here. And what you can do is also access it by the following URL, and this URL I'll also put in the description of this video down below, which is at docker.com/products/docker-desktop/. Right, so we can see this is the page that we need to utilize, and we can go on ahead and download Docker Desktop. Now, it does have a few options here. You can see we have download for Mac if you're utilizing the Intel chip, for Mac on the Silicon. Then we have Windows AMD, ARM in beta, and Linux. So here are the options that are set. Now, what I recommend you do is go ahead and download it for your relevant operating system. So in my case, it's going to be Windows on an AMD 64. Apple Silicon is typically for the M chip, so this is going to be the newer Apple devices. For older Apple devices, they will usually follow the Intel chip. Right, so let's go ahead and install it. So I'm going to choose download for Windows. It's just going to download the setup wizard for me, so just need to be a bit patient while that gets created. Okay, any moment. So let's just wait for that to be downloaded. Right, so let's go ahead and open up the setup wizard. Okay, so what's going to happen now, it's going to load up and your computer will dim if you're on Windows, and you just want to say yes and accept the security message. You might get something similar to that on Mac OS. And now you can see it's going to initialize Docker Desktop for our system. It's going to verify the packages and such. And you can choose if you want to add a shortcut to your desktop. I'm going to leave it as is and just say OK. And there we go, it's going to unpack all of the files and install. Now this process is going to take some time, so I'd recommend you just be patient. It's going to take quite a while. I can't give an actual estimate here because it's going to depend on your internet speed, etc. But just go on ahead and take some time and return in a while, and then you'll see that it will be installed and set up. So what we're going to do is just give it some time to install, and we'll return once it has been installed on our system. Alright, so welcome back. So we can see now that Docker Desktop has been installed and we're good to go. So we can close this up now, minimize this, and here I have the shortcut available. So I'm going to open that up. It's just going to take a moment to open up. So let's just wait for that. So quite a thing is being observed here with Docker Desktop, that it does take quite a while, especially to get the engine started and such. Right, so here is the Docker subscription service agreement. So what you can do is view the terms if you'd like, but what you can go on ahead and do is just say accept. Okay, just going to take a moment now to open up, and here is the Docker engine. So you can choose to create an account. That is something you can do if you want for work or for personal, but we don't really need to do that. We can just go ahead and say skip. Okay, there is a survey here which you can fill out if you so desire. So it's just a welcome survey of sorts. I'm going to say skip. And here we go. Our Docker engine is starting up. We can see the engine is starting here in the bottom left corner. And we just want to maximize this here. You can also see if you go to your shortcuts here, you should also see that the Docker desktop engine here is starting. You can see we have an indication of that right there. Okay, so it's going to take a moment, and just close that. And once the Docker engine has loaded up, we can then go on ahead and go further. All right, so welcome back. So as we can see now, our engine is running, and we now can see that the Docker desktop engine has successfully loaded up correctly. So as we can already see pointing out at us, this will be the section for our containers. We also have a section for our images as well, which is going to house all of our local images and also our hub repositories, as we can see. All right, guys, so that is how you can go on ahead and install Docker locally on your machine. All right, so the next thing that we want to do is we want to evaluate the differences between a Docker image and a Docker container. So this is something that I kind of teased, you could say, earlier on when we installed Docker locally by just perusing through it. Right, so Docker images versus Docker containers. A Docker image, simply put, is a packaged app. This is like a blueprint. Then we get a Docker container, and this is essentially a running instance of that image. So it's essentially a working product of that particular blueprint that you provided, for example. So let's go ahead and dive deeper. So a Docker image. A Docker image, like I mentioned before, is like a blueprint. And it is basically like a read-only template that contains everything that your app needs. This will include the application code. So for example, for your Python app, your runtime, this could be your Python version, and the libraries like, for example, Django or Flask. And this will also include any system settings. Right, so let's take a look at an analogy to better understand what a Docker image is. So think of a Docker image like a frozen pizza. I know this is quite abstract, but bear with me. So you have a frozen pizza in the freezer. So a frozen pizza has everything ready. The dough, the sauce, the toppings. But you can't eat it yet. You need to put it in the oven first. So try to relate to the dough, the sauce, the toppings, and everything on the pizza as everything that is part of your Docker image with all of the configuration settings, the runtime version, the application source code, and everything. Try to think of it like that. And then your Docker container, if we dive deeper into that first, it's essentially the running version of an image. So it's like taking a Docker image and actually running it. Okay, so you could say that the Docker container is the running instance of your Docker image. It's your Docker image that is running. And this creates an isolated environment for your app. So that is all separated and in place with your Docker container. And you can start it, stop it, and even delete your containers whenever you want. So let's look at this analogy now on this follow-up. So think of a Docker container now as baking the frozen pizza. And you'd be baking that pizza in the oven, and then of course you can eat the pizza. So the frozen pizza is your Docker image. Okay, and your frozen pizza is now cooked and ready to eat, and that's going to be seen as the container. Okay, and you can make multiple pizzas, which means you can run multiple containers from the same image. But we're not going to dive too much into that because that is bridging on to intermediate, but that is just a general understanding into that. Okay, so that is how we can compare the two in terms of a Docker image and a Docker container. Right, so we just learned what is the difference between a Docker container and a Docker image. Now, there's just two commands I want to show you, kind of a preview for our upcoming lesson on the main Docker commands. I just want to give you a little bit of insight. So what you want to do now is you want to open up your CMD or your command prompt if you're on Windows. If you are on macOS, you want to open up your terminal. Okay, so here I'm going to look for CMD. That's going to spell out command prompt. I'm going to open that and I'm just going to adjust that. And we can say CLS, that's going to clear our command prompts. If you're on Windows, you'll type in clear. Right, there we go. Now, what you want to do is you want to go ahead and say Docker images. And this is going to output any Docker images that we may have. So as you can see, we don't have any Docker images at the moment, but when we later on create a Docker image, it's going to be listed out here in our terminal. If you also want to see a list of any running containers, so if we have any containers that are currently running and they haven't been stopped, you can go on ahead and just say Docker PS. And that's going to output the list of all of the containers that are running. And you can see it's also going to provide you with some information in terms of the container ID, the image that has been transformed to run as that container, the command, when it was created, the status, the ports that have been utilized, and the name of it. And of course, earlier on with the Docker image, it's going to show that repository, its tag, its image ID, when it was created, and the size of the Docker image. Okay, so I'd recommend you just keep your CMD open if you're on Windows. If you're on macOS, make sure you also keep your terminal open as well. Just for the time being, we are going to utilize that later on in this crash course. So just a little bit of a preview. I just wanted to mention that in advance, just to separate the theory and the practical just a little bit. Okay, so now what we want to do is we want to look at Docker registries. So let's take a look. All right, so a Docker registry is essentially a place where Docker images are stored and shared. And we get two types. We get a public repository. This is free for everyone. And this is going to be Docker Hub. And Docker Hub is a typical example of a free public registry for Docker images. Now, there are also private registries, and these are for companies and teams, and these are typically used for internal projects. So let's take a look at private registries while we're on that note. So a private registry, as I mentioned, this is more or less utilized by corporations for the most part. And unlike public registries, it's only accessible to authorized users. So usually you would need to have an account and you would need to have everything linked and authorized in order to utilize them. Now, a few examples include the following, which would be Amazon Elastic Container Registry, commonly referred to as ECR. And this allows you to go on ahead and store your Docker images in a repository within the AWS ecosystem. You also get Google Artifact Registry, and you also get Azure Container Registry, referred to as ACR. So very similar to the wording in terms of ECR and ACR, to that note. All right, so that's all I wanted to mention in terms of the public and the private registries. We are going to take a look at Docker Hub, so stay tuned. All right, so let's take a look at Docker Hub, which is a public registry for Docker images. We can just type in Docker Hub in our search engine and say Google search. And there we go. We can see the first link here, Docker Hub Container Image Library. Click on that. Okay, I'll just take a moment to load up, and there we are. So we're at hub.docker.com. So that is the URL, which I'll also put in the description of this video if you want to go directly to there. And here we can see is the official repository with all of the relevant Docker images. As you can see, there's quite a few here that we can utilize. So we have, for example, databases and storage. We have a Postgres-based Docker image, MySQL, Mongo, and then we can also look at the developer tools such as Gradle, Bash, etc. And you can just browse through all of these at your own leisure. Right, now what you can also do is you can also go ahead and view the curated catalog here as well. And that's going to show you the Gen AI catalog in terms of what is available here. Okay, so here it shows us all of the MCP servers, which are correlated with Puppeteer, Postgres, GitHub, File System, Brave Search, etc., and all of the like. Now, what you can also do is you can also search for a particular Docker image. So let's say Python. So I'm going to type in Python. Okay, and we can just go ahead and choose Python. Okay, it's just going to load for us. And here we can see it takes us to a page where we can access the official Docker image here for Python. And we can simply utilize it by just saying docker pull image. And if you scroll down here, you'll also see a lot of tags here. So you'll see, for example, 3.14.0a5-bookworm. And if you scroll all the way down, you'll see more or less the older versions here, all the way to 3.9.21-alpine 3.20. Okay, so these are image versions, and this is something that we're going to cover soon enough. But I just wanted to at least take you through to Docker Hub and give you a little bit of insight in terms of exploration of the Docker images that are available to us. And you can just go ahead and search here for anything that you feel is relevant. For example, let's say we want to look for Ubuntu. And there we have it. We can click on that and that will take us to the official Docker image for Ubuntu if you want to utilize that in some fashion. All right, guys, so I'd recommend you just stay on this page for Python for the meantime. In terms of the practical, we will return and continue. But that's it in terms of the public registry, and this is Docker Hub where you can go ahead and utilize them for free. All right, so let's take a look at Docker image versions. All right, so Docker images, as we saw earlier on, have different versions, just like software updates. So the whole idea of versioning in software also applies to Docker images. So we have version 1, version 2, version 3, and then we also have version 1.1, version 1.12, version 1.13, etc. So the same sort of principle applies to Docker images as well. Now, these versions are saved on Docker Hub, as we saw, which is a library of ready-to-use images, or in a private storage. Now, each image has multiple tags, like labels you could say, and this helps you to pick the right version for your project. Okay, so we're just going to look a little bit deeper in terms of the Docker images that we get, and then we'll continue to focus on actually obtaining a Docker image and then transforming it to run as a Docker container. Right, so stay tuned. All right, so let's continue with Docker. Right, now we are going to utilize the Python Docker image later on in this crash course. We do need to configure our Docker file for this to work properly. So in the meantime, we're going to do a simple test just so you can become comfortable and familiar with the commands. So what we want to do is search for Nginx. So Nginx is essentially a web server, and we're going to utilize this as an example. So here we have it. We can see the official Docker image here is based for Nginx. We can see it also has a set of relevant tags here that are available as well. Now you'll notice here that we have latest here as a tag. Now it is the best practice to rather use a specific version instead of utilizing the latest version here. Okay, because usually with the latest version, there's usually always some sort of issue like a bug or some glitch going on. But also, in most cases, it's best to just choose a version that you really want to utilize. Okay, so I'm looking here and I am liking, let's see what we got here. We've got 1.27.4 and I'm liking this particular version. So I want to use 1.27.4, for example. That's what I want to use, this version here. Okay, and it's going to be based on Nginx, so we would utilize the syntax of docker pull, refer to the name, which is Nginx, and then we want to refer to the specific tag that we want to utilize with it to pull the Docker image from this particular registry. Okay, so what you want to do now is you want to head on over to your terminal. So remember, if you are on the command prompt on Windows, you can type CLS to clear everything. If you're on macOS in your terminal, you can type clear. Okay, so what we want to do is type in docker pull, and we want to pull a specific image, and that's going to be from nginx. So I'm going to say nginx : and then you need to refer to your tag. So here I'm going to use 1.27.4. So what I'm going to do here is go ahead and just say 1.27.4. And that's going to pull that Docker image from me from the Docker Hub registry. We can see it's pulling it. It's also downloading according to a set level of threads here separately. Okay, it shouldn't take too long. Okay, there we go. So it's downloaded that image from, of course, docker.io, the nginx library. Perfect. So well done on pulling your very first image from a Docker registry. So we can now confirm this if we head on over to Docker Desktop, where you should now see your Docker image. So we can see here we have nginx, the tag 1.27.4. We can see the image ID, when it was actually created, and the size of this Docker image. Now, sometimes when you open up Docker Desktop, you won't see your image immediately. That does happen. So what you can simply do is just close Docker Desktop, and you can reopen it. Or what you can do is you can go ahead and click on the icon. You can right click on it and say go to the dashboard. And that's going to reopen for you. Right, there we go. Okay, now let's say we have this Docker image and now we want to transform it to run as a container. So to start this up, so we can view it here in our container. So what you can do is we can clear this up. You can say docker run, then you need to refer to the name again. So the name was nginx. Now, if you need some clarity here on the specifics, you can see the name and the tag reference. So remember, if you're pulling or you are starting a container, you always refer to name, tag, name, tag. So again, here we're going to say name, and then the tag will be 1.27.4. Doing 27.4. It's going to run. Okay, you can see here it's going to go on ahead and set up our container. You can see we've got all of these logs here in the terminal. It's quite ugly here because it can, how can I say, cause a lot of clarity here in terms of too much information appearing in the terminal. I will explain how you can also omit this so you don't see all of this and the container runs in the background. So we can see that the worker has started and the entry point has been based on nginx version tag 1.27.4, and the configuration is complete and ready for startup. So you can now look here on your image and you can see we have this green icon and it is in use. Now you may not see this depending on the Docker Desktop version that you're using, but we can see that we have an image in use, and you can now head on over to containers. And we can see that our container is currently running. We can see it's got a name here. Now, if we don't define a name, it's not going to go on ahead and just allow us anything. It's going to just generate something for itself. We can see we have a container ID here, and we can see that this container was ran and transformed from the following Docker image according to the name and the tag here, which we used to run it. Okay, so that is how we can also run our Docker container, so how to start it. Okay, now the next thing that I want to go over is how you can go on ahead and view the logs of a running container. But before we do that, let's utilize the commands that we did before. And what I'm going to do now is I'm going to stop. So I'm going to press Control-C. And here we are essentially stopping the container. So now you can see it is now offline. We can see it's not running. We've got nothing running here. And we can see that even though we have binded our image to run as a container, we can see it's still here and linked, but the container is not running now. So if you press Control-C, that will stop running your container. But that's something we'll get to in greater detail. Okay, now if we were to run Docker images, we can now see that we have that Docker image, which is nginx. We can see the tag, we can see the image ID when it was created and the size, and that information is what you can also see right here in the images section here of Docker Desktop. You can see that that has been phrased accordingly. Now, if we were to say docker ps, Okay, you can see now that we don't have any of that information being shown here in terms of the container that is running, because we don't have a container running at the moment because we stopped our server. So if you press Control-C, it stops your server from it stops the server from running and your container from running, should I say. So let's go ahead and rerun that, rerun our container. So what I'm going to do is say docker run, and then we want to say nginx colon, and then 1.27.4 as a tag. Okay, and that's going to rerun your terminal. There we go, it's up and running. Okay, let's go to containers, and you can now see that it's created a new container under a generic username with a new container ID, and we can see it's currently in the running state. Okay. Now, let's say you want to carry on utilizing your terminal and you want to go on ahead and perform more actions. So we have this CMD running, our nginx container here, as you can see in this command prompt. So what you can do if you're on Windows is you can open up another CMD, or if you're on macOS, you can open up another terminal. So I'm going to do just that. Okay, so I have a fresh one here open. Let's just clear this up. And we can see we've got this running. So what I'm going to do is minimize this. And open the other terminal as well. And I'm going to put them side by side. There we go. So here I can see my container running on the left-hand side. And here what I'm going to do is I'm going to simply go ahead and issue some commands. So let's do it again, docker images. Okay, I can see there I have nginx, I can see the tag, the image ID, etc. But now let's put in docker ps. And as we can see now, it provides us with the information there about that container. So if I maximize this, we can see in terms of the container ID, we can see the image, command, created, the status. So we can see we've got the ports as well. We can see the image and we can see the names here. So we can see nginx 1.27.4 and names. So the name of the container is underneath. On the top there, it shows the image here according to the combination of the name and the tag. We can see the command that's been utilized when it was created, the status. So we can see that this is the Docker container that's running. So it's by utilizing this command here, it's going to show the list of running containers. So we did earlier on have a container that we used before, but you can see that it's not online and it's not running at all. This one here, which is called Fervent Villani, should I say, is now the one that's currently being ran. We can see the container ID, which is output up here. And we can also see the port that it's running, which is on port 80 on TCP. And we can see all of that information. So we can also clear this out. Okay, so that is how you can go ahead and just evaluate with a few commands. Now, another thing I want to show you is how you can view the logs of a running container. Okay, so what you need to do in this case is you need to refer to your container ID. So what we can do is we can go ahead and open up our terminal here. And I'm going to say docker logs. And what I want to do now is refer to the container ID. So you can see it's specified here in Docker Desktop for you. You want to copy the container ID of that particular container that's running. And you want to paste the ID in. Press enter. Okay, and then it's going to go on ahead and just give you some additional information here pertaining to that particular container, just to show you the status of what is occurring here with your container and how everything is being unfolded and all of the necessary details that's being output, as you can see. Okay, so what we want to actually go ahead and do now is we just want to go ahead and get a little bit more information in terms of the, how can I say, the logs that we are utilizing. So let's go on ahead and do just that. Okay, so let's do that. All right, so what you can do now is you can just clear this up and you can just say docker stats. Okay, and that's going to go ahead and provide you with a little bit more details here. So this is kind of similar to the logs in a sense, where it's just going to provide you more with resource usage. So here you'll see the CPU usage, the memory, the limit, and then the net in, of course, the net IO as it is occurring here, container ID, and the name of the container that you are utilizing, etc. So that's how you can check the resource usage of your container as well, along with the general logging. So here's just some additional logging information in the form of resource usage with the stats that we are utilizing. Okay, we can stop this as well. Clear this up. Okay, and just make sure throughout this entire process that you still have your container running in this particular terminal. Just make sure that you haven't gone ahead and, how can I say, stopped the wrong one. Now, let's say for argument's sake that we want to, for auditing compliance, see all of our containers, even the ones that have been stopped. What you can do is go ahead and say docker, and then you want to say ps, and remember this command is going to show your containers, but let's say you want to see the stopped ones as well. You use the same command, but you'll say -a, and that's going to show all of the relevant containers that you have in Docker Desktop. So we can see we have this nifty Morse, which is the name in my case of this stopped container. So if you want to see your stopped containers, you'll go on ahead and see it as such. So remember, you want to add in the A flag. That's going to list all of them, including the ones that have been stopped as well. Okay. Now, another thing that I want to show you is, let's say for argument's sake, you want it to run a Docker container, but you don't want to see all of these horrible logs here that are showing, as we can see for running this container, Fervent Villani in my case is the name of it. You don't want to see all of these logs being output and all of that. You want it to be quite clean and you want it to be easy. So what you can do is, let's go ahead and stop this. So I'm going to stop this here, type CLS. We can go back and we can see we have no containers running, but we can see that our image is ready to be ran as a container. So we can head on back and you can utilize either terminal. And what you want to do now is you want to go on ahead and say docker run, and you want to utilize the flag D here, so -D, which stands for detached mode. So this is going to prevent your terminal from being flooded with all of those logs. The same principle applies. You need to refer to the name. So that's going to be nginx : and then we had 1.27.4, and you can go ahead and say run. That's just going to output the relevant ID now. And now if we go to containers, we can see that we have this container running and it doesn't output all of those horrible logs for us. And it also just prints out that container ID, which we see right here. And it is reflected as soon as we run our container. Okay, so that is how we can go on ahead and ensure that we run clutter-free, without any of those issues or anything of the like. Okay, so that's it in terms of the main Docker commands that we use. So the main one is focusing on pulling an image from a registry and creating and starting a container from image, and also just a little bit on how we can partially stop our containers, especially in the terminal that we're running. Now, there is more detail in how we can stop and also remove and delete containers. There's a lot more to that, but we are going to get to that later on in this course. But that's just the fundamentals that you need to know in terms of the main Docker commands that are out there. But there's more to come, so stay tuned. So what we can do is just close this. And what you can do is you can keep both of these terminals open. We are going to do some experimenting, so I'd recommend you just keep everything as is, because there is going to, of course, be more to come. Right, so let's take a look now at port binding. So port binding is best explained in the process of how the Docker containers network works. So when you run a Docker container, it's going to have its own internal network, and this is separate from our computer. But if our app, in other words, our web server, for example, runs inside the container, the question becomes, how do users access it from outside? And this is where port binding comes into play. So let's take a look at how port binding works. So port binding, for example, this is giving your container a door. And inside the container, let's say our app runs on port 5000, but it's locked inside. Outside the container, okay, you need to bind it to a port on your computer so it can be accessed. So think of your container like a house, and without a door, no one can get in. So for example, we can say on port 8000 is our host port. Now this is the door on our computer where users can enter. And on port 5000, in other words, the container port, this is the room inside the container where the app runs itself. Right, so let's continue looking at this process. So let's say I have a container port, and inside the internal network of my Docker container where my app is running, it's running on port 5000. Now, I cannot directly go on ahead and access port 5000 on my computer and try to access a Docker container itself, because it's not going to allow me. I need to instead go on ahead and set the host port here via port binding so that I can access my application running in the container port. Okay, so you cannot directly go ahead and access your container. You need to utilize port binding, so you bind your host port and your container port together so that you can access your application running within your Docker container inside its internal network. So just one last thing in terms of the standard for ports. Now, it's recommended to use the same port for both the container and the host to avoid confusion, and it also helps to make debugging easier. Okay, but we're going to keep it a bit simpler. I want to show a distinction between the container and the host port for now, but in future, when you get more experience with Docker and you're working with it a lot more and you're getting more comfortable with it, then I would recommend trying to focus on keeping the container and host port the same. But just for this exercise in this crash course, I'm going to show you a clean distinction so that you understand it first, and then later on you can take this knowledge and then just remember what I said to go on ahead and remember to try to keep it similar as if possible in the future. All right, so let's look deeper into how port binding works. Now, the first thing that we want to do is we want to go ahead and see what will happen if we try to directly access our Docker container, what the result will be. So as we can see, our Docker image is in use and it's currently linked to this Docker container here that's currently running. And what we need to do first of all is we need to check the port that this Docker container is running on. So I can open up my terminal and I can say docker ps. That's going to show my running container. So I can see here I have this particular container running, and we can see the port that it's operating on is on port 80. So let's say I want to directly access this without specifying port binding from my computer. So I can just put in localhost, which is at my computer, and I'm going to say :port 80, which I've added here in my URL. So if I go ahead and press enter, it's just going to load and say this site can't be reached and that it refused to connect. So what we need to do here, of course, is we need to set up port binding. Okay, so let's head on back. And what we need to do is open up our terminal, or one of them at least, and we can just clear this up. And what you want to do is you want to ensure that you are running port binding accordingly. So the first thing that I would recommend you do is to stop your container from running. Okay, and I'm just going to show you how you can go ahead and do this. So I'm going to head on to images, go to containers, and here we have this container running. I'd recommend you just stop it here manually in Docker Desktop. So you can click on stop. There we go, so we can see it stopped, and we're good to go. Let's go back to our terminal, and let's go ahead and rerun a container. So I'm going to say docker run. And again, we don't want to have all of that terminal output. We can have -d, and then we can specify port. So I'm going to say -p for port. And then it's going to take in two parameters here. It's going to take in the host port and then the container port. So on my computer, I want to be able to connect via port, let's say 8000. And the container port, which we saw, was on port 80. So we can say 80, okay? And then we're going to refer to our particular image that we want to run. So nginx :1.27.4. So we can go back there and say nginx colon 1.27.4. Okay, now all of the Nginx containers are going to run on port 80. So even though earlier on the one that we tested here was on port 80, all of them are going to run on port 80 because that's going to be the default port for Nginx itself. So I just want to clarify that in case you're just wondering about if it will be different. It's not going to be different. So let's go back and run this. So there we go. We've got that ID of that container. Now we can just go ahead on and check if it's running. So if we go to containers, we can see, there we go, it's currently running. And we can see the port has been attached here in Docker Desktop. So our container port is, our host port is linked to our container port on port 80. And we can see it will be applicable if we now go to port 8000 on our device. So now if I go and utilize port mapping, which is now linked to port 80 via port 8000. So if I say colon 8000 now, which is on my host port on my computer, that's going to automatically bind me to port 80. And here I'm now able to access my container itself. Okay, so that is an effective way in which you can utilize port binding. All right, so there we have it. That is how you can utilize port binding for your applications. Right. So let's continue and focus now explicitly on how we can start and stop our containers. Okay, so earlier on, I did show you how you can manually stop a container by going ahead and stopping it right here within the Docker Desktop directory. Okay, so what we want to do now is head on over to our command prompt. Now you can close one of them now. We don't need two, or terminal, should I say. Because remember, when we are running our container, we're using the -d flag to ensure that it detaches it and runs in the background instead. Okay, so Docker PS. So we have one container that's currently running, and earlier on, just to summarize from port binding, you can see here what I mean, that we have our host port at port 8000 that is currently being mapped to port 80, which is on the container port. Right, so enough of that. What we want to do now is we want to stop this container. So we know how to do it in Docker Desktop, but how do we do it here? By typing in the commands. So to do so, you would need to say docker, and then you need to say stop. Then you need to refer to the container ID, so you can technically get this from Docker Desktop. We can see we have it right here for this container that is currently running. So you want to copy that container ID, head onto your terminal, paste in that ID, press enter, and that's going to output that container ID, and it will also stop your container. So if you say docker ps now, you're going to see no containers are running, and as you can see, it now has stopped. Okay, so that is how you can stop your containers. Now, let's say we want to restart one of these containers here. So let's say I want to start this one here, which is the sad one. That's the name of it. So what I can do is head on to my command prompt. Let's clear this up, and I want to say docker start. Then you need to refer to the container ID. So here I can see the container ID is visible for me. I can copy this, and I can right click, press enter. That's going to start up that container again for me, so I can see. There we go, that container is now up and running, and it's good to go. And you can confirm this by saying docker ps again, and that's going to show a list of running containers that are in play. Now, technically what you would usually do to reference this is, instead of using Docker Desktop, you would list them all out, and then you will pick a particular container that you want to essentially go on ahead and start or stop. So let's say I want to start a container from this list here, instead of browsing the cheat way or the easy way in the Docker Desktop. I can see here I have the container IDs. So let's go on ahead and say, okay, I want to start. Let's see what we have. We can see the status here, so we can see this particular container is up and running. I want to start this particular container here. We can see the name is fervent. Fervent is currently not running, so I can go ahead and say docker, and we want to say start, then we can just go ahead and refer to the container ID. So here we have the relevant one. We can copy that, paste that in. There we go. So it's now starting. So now if I head on back, we can now see that that container is now starting as well. So I have two containers that are currently running. So it can get a little bit chaotic here in terms of the container memory usage. However, you can see we're really well under a low usage, so we're good to go. But you never know, you might have containers that are very CPU and memory intense. Okay, so let's go ahead and clear this up now. And let's just say docker ps. Right, we've got two containers currently running. Let's go ahead and stop them. So docker stop. Let's refer to them. So we can refer to the IDs here as well. So let's stop sad. Copy that. Paste. That stops that one. It's just going to output the container ID or a partial part of it. Docker ps. Okay, we only have one running. That's the one we recently just went to run. So we only have one Docker container running. All right, so that's the easy way in which you can go on ahead and, how can I say, select containers up again, and how you can stop containers, and how you can go on ahead and do so in the terminal. Now let's say we want to go on ahead and focus more here in Docker Desktop. You can, of course, select it as we saw earlier, and you can go ahead and just say stop here, or you can say stop there, or you can pause it. So let's say we want to stop this container from running, and let's say we want to start it up again, but we don't want to use the terminal. So we'll select it, and then here we'll have a play icon. You could almost surmise that as. You can say start selected items, or you can click on start here, and that's going to start your container. Now let's say you want to run all of your containers, a bit crazy, but we would want to go on ahead and select the necessary ones that are still here. Select all the checkboxes, go ahead and say start, and that's going to start all of your containers for you. So we can see we have all containers running, and now let's clear this up and say docker ps. And we can see we've got all those containers running here. So we can see 1, 2, 3, 4, and the status here, when it says up, it is an indication that your container is running. Okay, if you see it's exited or something of the sort, that is a smart indication that that container is no longer running. Okay, and now let's go ahead and stop them again, the ones that we just selected, and say stop. Okay, so we have one running as of this moment. We can uncheck everything else. And if you want to start all of your containers in one shot, or you want to stop them all in one shot, you can click on the checkbox above here, and then you can utilize this multi-select to go ahead and do all the options in one shot for you. Okay, so that is how we can start and stop containers. Now, I want to show you a few extra things here just to enhance your learning, so feel free to stay tuned for that as well. All right, so let's continue. Now, what I want to do now is I want to go on ahead and remove containers. So let's say I have a container here up top. I want to actually remove 3 containers here. 1, 2, 3. And actually, let's just delete 2. Let's not go crazy. I want to delete 2 of these containers. I can just say delete here. And you want to say delete forever. And that is how you can utilize a dashboard in Docker Desktop to delete it here. Now I'm going to show you the equivalent for the command to remove or delete a container. So we can go to the prompt, and all you want to do is you want to say docker rm, which stands for remove, and then you want to refer to the container ID. So here, for example, we have this container that's not running. I want to copy the container ID, and I can paste it right in. And press enter. That's going to go ahead and paste out that particular Docker container. If I head back, we can see it's now been removed. You can do the same thing if you were to go ahead and say docker ps. You can also go ahead and copy that relevant container ID and utilize that short ID instead if you also want to remove your container as well. Okay. So we'll get to that. Now what I want to show you is how you can create a container, but you actually name your container this time, and we want it to run in the background so we don't see all that terminal output. So we're going to go on ahead and add in quite a lot in one shot. So we'll say docker run, and then you want to specify a name. You can use the -- name flag and then give a name for your Docker container. And we can see we've only got one running with its own custom name. So I'm going to say here unique _ flow. That's the name of my Docker container. And what I want to do is I want to go on ahead and ensure this is going to be silent. So I'll have -d, so to detach it, so I don't see all the logs in the terminal, so I don't need to open a new terminal. And then we want to refer to the name and the tag of the image that we want to transform. So nginx and the tag 127.1274. So then we just want to say nginx : 1.27.4. Okay, there we go. We can see it outputs that container ID for us. And if we go to containers, we can see we've got this container now running. And as you can see, it has its own name now. So that's how you can assign a unique name to your Docker container. And we can see it's binded to that same image. And of course, since we get the output here in terms of the container ID, the longer version, that it is in fact running as it should. Right, let's say docker ps. Okay, we have two containers. Now, what I want to do is I want to stop this other container that I had from before. And what I can do is I can just simply say docker and stop. And then I want to refer to the short container ID that's been posed to me here. So I can go ahead and copy that, paste it out here, stop it. It's going to output that particular value. If I head on back, I can now see that that particular container has stopped. Now I want to delete it. So let's clear this up. Docker ps. All right. And we can see it's been stopped, but now I want to remove. So docker ps-a. You can see it is still visible right here. So I can just say docker rm. Then you want to grab in that particular ID that's linked to it. So I have it down here and remove. There we go. So it's been removed. It outputs on a new line that code. And there we go. We can see it has been removed. All right. So that is how we can go ahead and remove our containers and how we can start them and all of the lot. Now, what you can also do is you can refer to the name of your containers as well if you want to go ahead and delete them. So let's go ahead and do just that. Right. So here we have the name unique _ flow. Let's close this up. Docker ps. Okay, unique flow, which we have here. Now I'm going to say docker stop, and I want to refer according to the name of the container. Copy that, paste, enter. Going to print out that container name, and we can see it's been stopped. Now let's stop it let's remove it now according to the name. So I can just say docker rm for remove, and then you just want to go ahead and repaste in the name. And that's going to remove it for you. So if you head onto containers, we can see we have no more containers that are running. Simple. Let's go to images now. Okay, we can now see that none of our images are binded to any containers at all. So we can see that it is now unused. So now we can go ahead and remove this image. So I'll show you how you can remove it. You can click here on the checkbox and say delete. Or what you can do is you can go to your terminal and delete it directly from there. Now keep in mind that to remove an image, you need to refer to your image in terms of the tag. Okay, so let's go ahead and do just that. So I'm going to head on over here and we can say docker, and it's going to be RMI, so standing for RM remove I image. And then we want to refer to the tags that have been associated. So in this case, it's nginx 1.27.4. So we'll say nginx 1.27.4. And we can see it's been untagged and it's been deleted. So if we head on back, we can see we've deleted that image. So you're going to put in the name of the image and the tag. So name and tag, name and tag. That's to remove an image from the terminal. All right, so there we go. So a few extra commands I also wanted to show you just to give you a bit of emphasis and to teach you the distinction to utilizing the desktop itself, and also how to use the terminal equivalent commands as well. All right, guys, so that is it for this part. All right, now the next thing that we want to do is we want to look at a Docker file and the composition of it and such. So the first thing that we're probably wondering is, what is a Docker file? So a Docker file is essentially a simple text file with instructions on how to build a Docker image. Now, in terms of what it does, it tells Docker what to include, and this would of course have information pertaining to the application source code, any dependencies or specific settings that need to be in place. It also defines how your Docker container should run. So we will have our Docker file, which contains a list of all of these instructions, which is then going to be instantiated to build a Docker image. Once that Docker image has been created, it's then going to be transformed to run as a Docker container. Now, just for extra emphasis, to be explicit here, a Docker file is used to build a Docker image, and when you run that image, it will then create a Docker container. Right, so that's it for the theory. Let's dive into the practical. All right, so the next thing that we want to do is to create our Docker file, and to better demonstrate this, I'm going to show you how we can apply this to a simple Python application. Right, so if I head on in Visual Studio Code, I can see I have an app.py file. So this is going to be a base Python application that was created utilizing Flask here. So essentially it is going to return hello world, and it's going to be ran on port 8000. Okay, so just to give you some extra detail here in terms of this application here, I won't go into too much detail, is that we are utilizing the Flask framework, which gets imported, and then we're going to create a Flask web app instance. Here we're defining a route, and this is going to be for the route URL of /, so that would be the base applications route. Then of course, as we know, we're going to return a message. This will be a response when we have accessed the base directory or the base URL of the application. And of course, we are specifying here to run the port on port 8000. Now, in terms of the host here being 0.0.0.0, okay, this is going to allow us to make the app accessible inside our Docker container, and then we're going to run the port on 8000 so that it matches what's exposed in Docker itself. Okay, so that is the basis of this app.py file here. We then have our dependencies in the requirements.txt file. So I've just added in Flask and Gunicorn or Gunicorn. So that is just the basis of dependencies here. So you can kind of see how the whole Dockerization process goes into play. Right, so now what we can do is create a Docker file. So I'm going to say new file, and you want to create a Docker file by saying Docker file, no capital letters, no spaces, all in lower case as is. Okay, so we can close that. And the first thing that we need to do is we need to import or utilize the base Docker image for Python. Okay, and to do so, we need to head on over to Docker Hub. And now's the time for utilizing Python. Okay, and here we have it. And we want to look for the relevant tag. First of all, let's look at the image that we're using, so Python. And we can just say from Python, colon, and then we want to refer to the tag that we want to utilize. So here we can look at the tags, and we're going to choose a specific version. I'll zoom in just a little bit more for clarity. So I want to use 3.12.9-slim bookworm. This is what I'm going to use, this one right here. You can choose whichever version you prefer. And I'm just going to paste that in like so. Okay, so this is very important. This is just going to specify that we're going to use this particular base image of Python to set up our custom Docker image, you could say. Right. Let's continue. Now, the next thing that we want to do is we want to set our working directory. Okay, and this is going to be the working directory that we set within our container. And this is going to ensure that all commands run inside our directory. So to do so, we can go ahead and say workdir, and I'm going to call it app. So I'll say /app. Okay, so it's going to be called the app directory, and this is going to be the working directory that will be in our container known as /app, or app commonly. Okay, now the next thing we need to do is we need to copy our current directory, so all of our project files, which are situated in our base directory, such as app.py and our requirements.txt file, into this app directory here. Okay, and that's going to be the containers directory, you could say, eventually, once we run it as a container and such. So what you want to do now is you just want to say copy dot /app. Now the dot part will refer to everything in our directory. Then we want to install our dependencies. Now in Python, we get a requirements.txt file, and we want to go ahead and install all of those dependencies. So what you can do is you can say run pip install dash, and you can say r and requirements.txt. Great, so we've got that set. And the final thing you want to do is you want to go ahead and specify the command to run our Python application. So it's going to be a Python application. We add the keyword here in double quotes, comma, and then the name of the script that you want to execute. So in this case, it's called app.py, and app.py will be specified right here. Okay, so that is this Docker file explained and how you can utilize it. Okay, so we've got that set. The next thing we need to do is execute the relevant command. Now, you could easily utilize the inbuilt terminal if you want to use Visual Studio Code terminal here, like we are doing. So you can click on the following icon, go to terminal and new terminal. That will output the following terminal here, where you can go ahead and enter in your commands like we've been doing throughout this course. Or what you can do is you can utilize your CMD if you're on Windows, or your terminal on Mac OS. And essentially what you would want to do is refer to where this file is. So in my case, I'll show you. It's minimized. Okay, so here is my file, my folder, excuse me, my Python-app, and I've opened it up here in Visual Studio Code, and it's on the desktop. So we can just see at each of the desktop where the folder is, my Python app. So I can go here and say cd, and I can just copy that path here. And there we go. All right, so that's just how we can just get access to this particular location that we are going to be executing said file. All right, perfect. Great. So let's go on ahead and continue. So now we want to issue the command. So first we want to build a Docker image, and this Docker image will then appear here in images here. So it's going to be like our own custom Docker image that we've created by issuing the relevant instructions to our Docker file. So we can say docker, and we'll use build, and then you want to add in the flag -t, which means tag. And essentially what that means is you need to pass through the name and the tag. I know it's kind of double rephrasing here, but essentially when we went ahead and ran our Docker container and we pulled the Docker image from the public registry at Docker Hub, we gave in the name and the tag. So for example, nginx :1.27.4. We're doing the same thing here. So trying to just learn this abstractly. I know the logic is a bit strange, but it will say -t, and then we can call the name Python, and I want to say 1.0 as the tag. Then you want to add a space and say dot. That's going to refer to the context of this particular project that we're going to create a Docker image for. And you can press enter. So it's going to take some time, and it's going to go through all of the relevant commands as soon as it's fetched the base image from the Docker Hub registry. And essentially it's going to go through all of the additional steps here in our Docker file. You'll see it's going to go and refer to the work directory. It's going to copy everything and associate it with the app directory. It's going to install our requirements.txt file packages, and it's going to do so by running the command of Python and app.py. And you can see all of this occurring here in the terminal. You won't see it just yet. It's going to take some time, but you will eventually see it occur here. But I'm not going to waste any of your time, so I'm going to pause the video, and you can see that process that I just mentioned being unfounded here as it goes. All right, so literally when I paused the video, it was just about finished. So we can see now that everything was completed in a stage of threads here, as we can see. we can see that it went ahead and completed the work directory line. It copied all the files and it installed all the packages and exported the image. And we can now see it has been built. So now you can go to Docker Desktop and you can see now that you've created your very first Docker image by utilizing a Docker file with all of the customized and specified commands. So we can see it's called Python 1.0. So that was part of the tag that we set. We can see the image ID, when it was created, and the size. So very well done doing that. Okay, now the next thing that we're going to want to do is to run this container so that we can access it. So we can just say CLS or clear, and you can say docker run, and you can say -d because we don't want to see all of those logs appear here in the terminal, and then -p because we want to add in port binding. And now we just want to specify the container and host port. So first the host port, I want to connect on port 8000, and the application here, which will be in, which has been Dockerized, will be available at port 8000. So we need to make sure that we have this here and it's going to match. Then we want to refer to the image that we want to transform to run as a Docker container, which is called Python, and the tag is 1.0. So we can just say Python 1.0. It's going to output that container ID that's unique for that container instance. We can go back to Docker and we can now see that this image is in use. So let's go to the container, and there we go. We can successfully see that this container is running, and we can also access it by just clicking on the following link here, and we can go ahead and do that. And there we go. We can see our application being run, and we have access to our container. It says hello world, and it's available at localhost 8000. So that is at our host port being connected to our application running on port 8000. All right, guys, so that is how you can go ahead and do the whole process, how you can create your Docker file, how you can build your Docker image, and how you can run it as a Docker container in the final part. All right, so that's it. The final thing that I'm going to do now is just clean everything up, and I'll show you an extra command. So let's go ahead and do just that. Okay, so you can either use Docker Desktop for this, or you can do it in the terminal as I've shown before. So let's do it in the terminal. So first we want to stop the container. So you want to say docker stop, refer to the ID. So we can just copy that container ID, paste that in. Okay. And there we go. So it went to the next line and it stopped. So it took a bit of time there, but there we go. We have it stopped. Now we want to delete it. So we can go ahead and say docker rm, refer to that ID again, call output, and it's gone. Now we can go to the container. Now, if you recall, let's just clear this up. We can say docker rmi, so remove image, refer to the name and the tag, so Python 1.0. It has been untagged and deleted. And there we go. Right, so something I also want to mention, in the future, if you are making changes to your application and the source code, what Docker tends to do is to cache your files. So if there is something that has already been built before, it's going to remember that code and it's not going to change it. It's going to build onto what new code you've adjusted or changed. Now, what you can do is to clear your cache, you can utilize this command known as docker system prune. And this is essentially a command to go ahead and do the following. It's going to remove all stopped containers. It's going to remove all networks not used by at least one container, all dangling images, and any unused build cache. So when we were building our images. So remember of the things that will be deleted when you run this, but the important thing that I want to elaborate on is that it's going to remove all unused build cache. So we can say Y and enter. And there we go, remove that cache and all of the space has been retrieved. So that's going to ensure clean builds. Now do keep in mind when you do this, your builds are going to be the same speed as before. If you let it cache and you change your application and rerun everything, essentially what's going to happen is you're going to build your Docker images faster. So try not to, how can I say, shoot yourself in the foot when you're doing this. You want to try and make sure that you get the most efficiency out as possible. But however, there are cases where it will be necessary, but we don't want to delve too far into that. All right, guys, so that is essentially it for creating a Docker image and how you can Dockerize a very simple Python application. And of course, that concludes this crash course on Docker. So thank you for watching, and I hope that you found it useful.